Okay, this is the fraction review part 10. This is an applied problem, and there are several different ways you can work this. We're asked to find the perimeter, which is the distance all the way around these figures. So really, all we're being asked to do is to add up all these numbers, right? So I'm going to talk about a couple of ways to do it. If you notice, we have a lot of the values that are repeated, right? Here, 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 and here, they are all the same fraction. These two are the same as well. Obviously, this picture is not drawn to scale because Microsoft Word. All right, so what we need to do is add all these up. Now, if you think about some definitions, if you're adding, this is just an aside here, if I'm adding 3 plus 3 plus 3 plus 3, that's the same thing as 3 times 4, right? Repeated addition is multiplication. So one thing I could do is I could take 3 and 7 over 16, and I have 4 of them, so I could do 4 times 3 and 7 over 16. That would give me how much these add up to. And then I could do the same thing here, except multiply it by 2, which is definitely an option. Okay, so I could do those and then add those together. I could convert all of these to improper fractions and then just add them straight up and then reduce them. But the other way I'm going to show you here right now is a way of adding a whole string of mixed numbers so that it might be a little bit easier. You have a lot of options here. Do not worry about it if you think another way is easier than what I'm about to do. Okay, what I'm going to do here is I'm going to kind of group these together. Okay, so I'm going to add up these three, but what I'm going to do first is I'm just going to add up the whole number part. So I have 3 plus 3 plus 3 plus 3. So I've used that, that, and that. Okay. Now I'm going to add the whole number part here, 6 plus 6. That's this and this. Okay. So this is just adding up all the whole number parts. You can think of this as kind of like when you're adding up money, and the whole number are $1 bills, and the fractions are the cents that you'll deal with in a bit. Okay, so I've added up all the bills now. Now I'm going to add up the fraction parts that are the same. I have a 7/8 and a 7/8. Which is this part and this part. Okay, now what do I have left? I have the 7 over 16 for these pieces. And I have 4 of them. Okay, so you can see here it's kind of deconstructed, but I've added up all the whole number parts, that's from these two, and then I've grouped my fraction parts together by whether or not they have a common denominator. It's just going to make it a little bit easier to simplify this in the end. Okay, so 3 plus 3 plus 3 plus 3, that's 12, right? Plus another 12. And I got this from here and this from here. Okay. Now, right here, they have a common denominator, right? 8 plus 8 and 8, so that's the same. This is going to be over 8. 7 plus 7 is 14. So I have 14 over 8 there. Okay, that comes from here. And then from here, 7 plus 7 plus 7 plus 7, that's 28 over 16. Okay, so I've added some of it, simplified it a little bit. It's looking better. Okay, now I can add these two parts together pretty easily, right? 12 plus 12, that's 24. All right, so I'm good there, 24. Now I'm looking at these, and I see that they will reduce, but I'm also seeing that if I simply divide this by 2 right here, I'm going to have an 8, and I'm going to have a common denominator. So let me just do that part. And like I said, I'm showing you a way through these problems, not the only way to get through these problems. So that would be the same as 14 over 18, which looks, it's the same as here. Okay, so I'm going to kind of, I've rewritten this. This is the same as this. So what I have here, I'm just going to rewrite my problem again. I have the 24 from here. This is from here. And this is right here. And now I have a common denominator here, so I can combine these. 14 plus 14 is 28 over 8. I can simplify this as well. Both of these are divisible by 2. So this is 24 plus, if I divide this by 2, divide this by 2, I get, I can divide both of these by 4. That's even better. 28 divided by 4 is 7. 8 divided by 4 is 2. Okay, so I'm getting there. What is this? Is a mixed number? 2 goes into 7 3 times with 1 left over. So this is 24 plus 3 and a half. 24 plus 3 is 27 and 1/2. And this is inches. Now I know this was long and involved, but if you followed along with this, you are in really good shape. Okay? All we've done is added these together. I could have used multiplication to simplify it. I could have changed them all to improper fractions and gotten a common denominator for the whole thing and then switched it up. But I also showed you how to add mixed numbers as they are and kind of regroup things. So I hope fractions are a little bit more clear now. One more thing. If you get confused about whether or not you need a common denominator, if you're looking at it and you've got a multiplication problem, say, do I need a common denominator or do I not? Do I need one or not? It is always okay to find a common denominator. Your multiplication and division problems are going to be bigger and uglier if you find a common denominator, but they will still work. Addition and subtraction never work without a common denominator. So you're better off getting one and when you didn't need it than you are if you just don't get one when you do. Okay, so end of fraction review.